Leology is the first testing framework for Leo programs. We developed it during the last DevConnect in Istanbul, and we won a hackathon prize over on it. So basically, the objective with Leology is creating a suite of tools that makes programming Leo program easier and to streamline development and be able to build high quality software in Aleo. Right now, all people who experience in developing in Leo programs, they must have noticed that, yeah, the tooling right now is like lacking. So basically, the first features we were focusing on were, of course, local setup program deployment. That it needs to be a must-have in a testing framework, like to improve the developer experience. Then we are trying to support all the Leo program features, like testing public records, private records, and all those kinds of flows. And then we develop a novel kind of bindings to allow this. To explain this, this is kind of an integration, a deep integration between Rust and Leo language to be able to auto-generate all the functions, access, and members of the Leo program and be able to call them in your Rust test. So we use macros for that in Rust. That is quite advanced, the development. And yeah, and then from now we are working on some more advanced functionalities, but we are working on this right now, like they are not yet ready, that are, for example, testing complex scenarios. That's something the developers would like to have. Like, for example, you develop a DeFi protocol, so you want to set up the different pieces of the pool, like liquidity, maybe some people swapping, account impersonation, simulating, more complex scenarios with mock transaction data. We have inspiration from other testing frameworks for that, like Foundry or Hardhat, that are able also to, for example, time travel or take a snapshot in a certain block to check if the condition of your program are meeting. And then after that, we are going to prepare some templates in the sense of boilerplates that maybe developers can leverage for hackathons to be able to set up a quick project with the testing integrating into it. And also the last step that we want to implement is nice output logs that are self-explaining for the developers, like recommending the changes in case a test is not passing, so the developers knows exactly where it's failing in the code to try to fix the test. And that's basically it. We were trying the demo, but these days everything is changing so fast, so the current code is a bit of broken. So the thing we managed, like our current flow is launching the DevNet that you can see in the left-hand side. I can do it. So in the left-hand side, we have the DevNet, that this is the SnarVM repository DevNet script.sh. It's just launching for validators and quite the standard. It's from the official SnarVM repo. And on the right-hand side, we are launching a Docker with the Aleo Explorer. So we did some changes to be able to connect to our local validator sets, and that allows us to have some visual feedback on how the test or the program we are testing locally can be checked. For example, in this program that is the .aleo was one we are creating testing for it. So you can see the times it was called, the recent calls, the functions. That's really comes from the Block Explorer, but since we are still like having some issues with the test, it's good to have this flow to be able to locate the issues and depurate, debug, all the things. Basically, yeah, that's for the code. We can show the bindings thing. Normally, what the developers want to do is to create this manually to define the functions on your contract and the signatures of each function. In the future, this will be auto-generated, but right now we are doing it manually. And from that, for this token code that is in Leo program, it's a really simple one, like the typical token. So we have like the function min public, min private, transfer public, whatever. So we create the test in, as we say, one of the functionalities is that we are using native Rust testing capabilities. So that's really useful because most of the developers coming to Aleo know a bit of Rust, so you don't need to have the learning curve to learn another language or another framework. Just use what you know of testing native Rust, and it will work with the test directive, and that's all. So we can set up the scenario we want, then we call the function in our program. As you can see, we directly call the method for the program, that is the token, without like doing complex things. That is really convenient, that you can just call the function like if you were directly on Leo language. We pass the parameters with the addresses we generated and the amount, and then normally you want to assert like the regular testing also, like where you arrange the scenario you need, then you act calling the method, and then you assert the result to check if the test is passing. And at that point, we cannot show a lot because it was working, but yeah, some changes prevented it to work, and we will show in the next demo probably. Is anything you want to comment?
Yes. I want to add that with these functions that we generate using the Rust macro, you get auto-completion automatically. So that way, normally you would use strings that could maybe be the wrong type. So with the automated functions, you don't need to worry about that.
Yeah, so basically that's it. We are working so fast, so probably in a couple of days there will be a lot of changes, but we recommend you to check our GitHub. We have different branches with different things we are working on. We are also on GitHub, on Discord, Telegram. If you want to contact us and maybe share your needs as a developer, we are right now hearing out the community to make this like the future, the standard testing framework for Leo. And that's all. Any question?
Oh, cool. Yeah, what I was wondering is how far along are you guys with like doing a protocol that like interacts with other smart contracts? Is there an example built out with your framework like that yet, or no?
Yeah, currently we just have this example, and the one I showed you, the token one. We have another one that is called Deb, is in another branch in our GitHub. But right now they are quite basic examples, like covering just calling function in the program and checking the output to assert the result. But in the future, we want to like streamline and customize. That's why we also internally fork the Snark VM and Snark OS to be able to hook into it and do more complex things. But this is the very beginning, so it's quite basic right now. But even though you can do some things, right? Like testing public records, private, and that helps. Yeah.
It's a typo in the URL, leog-org.
Which one?
GitHub.
Oh yeah, it's Leo. Yeah.
Yeah, because currently it points out to another
Thank you,
repo.
thank you. Yeah, I guess it. It's leology-or is this one. Leology. We also are building the documentation. We are also adding some documentation to be able to set up and do everything better, but we are working on it. And yeah, so this is the main repo, leology.org, leology. That's it. And yeah, we have here like some instructions to set up the environment, and you can also do the test. And in that branch, in the Henrik one, we have the other example to check. But as I say, these days are moving fast, so probably in a couple of days we will have a lot more. And that's it. Yeah.